Activity 9, Oceans and Climate. You have learned that the sun's energy heats Earth, including Earth's ocean. In this activity, you will find out how climate is influenced by ocean temperatures. Our guiding question today is, how do oceans affect climate? Today, we have 4 guests with us. We have Benjamin Franklin, an 18th century scientist, inventor, and statesman.
Hi.
We have Dr. Tansi Makaya, a climatologist.
Hello.
We have Bo Nye, a student moderator of Time Travel News.
Hi.
And Dr. Lena Reddy, a hydrologist.
Hi.
And they are going to have a discussion today about mapping ocean currents.
In today's episode, Time Travel News, we will focus on ocean currents and climate. Our guests include Mr. Benjamin Franklin, a scientist, inventor, and statesman from 18th century. Joining him are Dr. Lena Reddy, a hydrologist, and Dr. Tansai Makia, a climatologist. I have heard that there is a current in Atlantic Ocean that is slowing down. Some scientists say that this may cause changes to the climate of Ireland. How can that be?
All around the world, there are regular movements of large amounts of ocean water called currents. Some of these currents move warm water from one place to another, while other currents move cool water.
It sounds like you're talking about rivers, not oceans.
Some people describe currents as rivers that run through the oceans. Like rivers, these currents vary width and depth, but you can't see them the way you see rivers that run over and through land. They may be that 100 to 1,000 kilometers wide and flow on the ocean's surface or a couple kilometers below the surface.
One of the really important ocean currents is called the Gulf Stream. It is one of the strongest ocean currents in the world. It flows on the surface of the northern Atlantic Ocean and carries warm water from the Gulf of Mexico to northwestern Europe.
That warm water begins to cool as it travels north and eventually sinks. It becomes part of a cool, deep water current that then flows south from northern Atlantic towards the equator.
Measurements taken in 2005 showed that this cold, deep water current appeared to be slowing down. Ocean currents are like huge conveyor belts that move thermal energy from one place to another. The slowing of one part of the belt may cause another part to slow down too.
Let me see if I understand this idea. If the cold, deep water current is slowing, that could slow down the Gulf Stream. If the Gulf Stream slows down, less warm water will reach Ireland and northern Europe.
Yes, but saying that this will lead a significant climate change in Ireland is extreme prediction. There is no data showing that this will happen.
Mr. Franklin, you were one of those first people to chart the Gulf Stream. What do you think?
I'm afraid that I don't have enough information. And back in my day, we didn't have enough data to tell if ocean currents were speeding up, slowing down, or staying the same.
I still don't understand how ocean temperatures near Florida could result in a change in the climate of Ireland.
The sun's energy heats both land and water. You probably know that water heats and cools more slowly than the land. As a result, oceans retain a large amount of thermal energy. Ocean's currents move some of the thermal energy around the Earth.
I was one of the first to propose that wind is a major cause of currents near the ocean's surface. But what causes the deep water currents?
When cold water near the North Pole freezes to form ice, it leaves salt behind in the water that doesn't freeze. This water is denser than typical ocean water because it has greater concentration of water, salt, and it is really cold. It sinks towards the ocean bottom, then flows south. So the difference in temperature and the amount of salt in water drive deep water currents.
I see. Because they are denser, gravity makes those currents flow deeper in the oceans.
Wind blows some surface currents away from the equator towards the poles. A warm current, like the Gulf Stream, warms and moistens the air above it. The warm, moist air makes climates warmer and wetter than they would be otherwise.
Even to places that are far from the start of the current. Ireland is thousands of miles from where Gulf Stream Sea begins in the Gulf of Mexico.
Yes, since the Gulf Stream carries warm water, it makes the climate of countries in northwestern Europe, like Ireland and England, warmer and wetter than other places of the same latitude.
So you were saying that these countries have mild winters and warmer summers because of the Gulf Stream. If the Gulf Stream slowed down, less thermal energy would be transferred, and both winters and summers in these places would be colder.
Exactly. The Lake of Tralee, Ireland, has a mild climate because of the Gulf Stream. In January, it has an average temperature of 5 degrees Celsius, which is also 41 degrees Fahrenheit. In comparison, Petropavlovsk, a city of smaller latitude in Russia, has severe climate because of its cooled by a cold ocean surface current that comes down from the North Pole. It has an average January temperature of -8 degrees Celsius, which is also 18 degrees Fahrenheit.
You may heard of El Nino. During years when El Nino occurs, the surface temperature of tropical eastern Pacific Ocean becomes a few degrees warmer. This usually results in change to local climates, like warmer air, temperatures, and more rain. It can also cause weather disasters such as floods and droughts.
I never knew that oceans are so important to climate and weather.
Ocean currents are not only affect climate, but they also affect businesses like shipping and fishing. Ocean and engineers are always working on a new and improved instrument to collect data about currents that make oceans navigation easier.
When I was a postmaster in the mid-1700s, we would send letters to England by ship. It took about 2 weeks for them to reach England, but it would take 3 to 4 weeks for letters from England to reach an American port. One day, I received a letter from the head of the British Postal Service asking why it took so much longer for mail to travel to the United States.
But did he already know about the Gulf Stream? I read that in the early 1500s, Juan Ponce de Leon of Spain explored the waters around Florida. He wrote about seeing ripples in the ocean moving faster than the surrounding water.
I understand that during Mr. Franklin's time, sailors familiar with the area knew approximately where the Gulf Stream flowed, but there were no accurate maps of the current.
So, Mr. Franklin, how did you investigate the Gulf Stream?
In 1775, 1776, and 1783, I was on ships crossing the Atlantic. I took measurements of the water temperature, speed, and depth of the current for 2 to 4 times a day by dropping a thermometer in the ocean. Then I recorded the temperatures on a map. I started to see a pattern of areas where the water was warmer and moving faster.
Mr. Franklin's measurements were used to construct the first scientific map of the Gulf Stream.
I also took daily air temperatures to help make maps of the Gulf Stream more detailed. Adding to my findings, fishermen and sailors told me about what they saw and experienced while sailing the Atlantic Ocean.
What did they tell you exactly?
The most fascinating stories they told were about catching huge fish known to inhabit the Gulf of Mexico up north near North Carolina in the United States. They also described the color of the water in the Gulf Stream as bluer than the rest of the Atlantic Ocean.
Today, new technology is used to measure ocean current temperatures more quickly and more often.
Are the measurements made with instruments on ships?
Some data are still collected that way, but most measurements are collected by instruments that scientists set afloat in the ocean. These instruments are dropped by boats or planes in specific places in different parts of oceans all over the earth.
Satellites pick up signals from these instruments and relay the data to scientists. With this data, we now have maps of temperature, speed, and salt content of different ocean currents. These maps can be updated every week or month.
There are also instruments kept on ships that link to satellites. People with smaller ocean-going boats sometimes buy these instruments so they can download images of ocean currents to use for the navigation.
Amazing! Such accurate and up-to-date information must make sailing easier and safer.
I would imagine so. How has this information changed people's understanding of ocean currents?
Now we can see the details within large ocean currents. There may be smaller currents and different temperatures within a larger current as well, as you can see on the temperature map I bought.
We can also compare the speed, temperature, and salt content of the currents from the year to year and tell, for example, if currents are slowing down.
So the information collected from these instruments showed that the climate of Ireland may change?
Not exactly. Temperature and water speed measurements were collected in 1957, 1981, 1992, 1998, and 2004. In one study, scientists compared 5 sets of data and concluded that the cold water current flowing from the North Atlantic towards the equator has slowed down.
So that's why they're protecting that the climate will change in Ireland?
A slowing of the cold water current could result in the slowing of the Gulf Stream. This would mean less thermal energy transfer and a cooler climate for Northern Europe.
That's one way to interrupt the data. Another interruption is that the slowing of the ocean currents is a part of a cycle that reverses itself every 100 years or so. If that is the case, the current may again speed up. The climate of Ireland would not change so much.
It sounds like more data needs to be collected.
So it does. We'll have to keep an eye on the latest news in the meantime. A big thanks to our guests. Join us next week for another episode of Time Travel News.
Yay!